Alright, so I'm gonna just work through showing you how black holes work as far as I can see them in this drawing. With drawing, sorry, not in this drawing. We're gonna use probably like a gray or a white for this. Will that work? Yeah, that'll do. Okay. First things first, we're gonna focus on this guy here. This little guy here with this little red part here and this little yellow part down here. Let me make that bigger. Oh, let me zoom in. Let me just, yep. Because what you're actually seeing here is a black hole. This is a black hole. Like right there is a black hole. You can actually see it. Anyway. So this is what two sides of a black hole would look like. I'm assuming there's a dark side and then there's a light side where it's ejecting radiation, because it seems to be that way. And again, this is just conjecture, so at best. So anyway, so we have our little black hole up here. What it is pulling in, right? Sorry, that's not very thick. What it's pulling in right now is this stream, right? And then what's coming out is this stream. But what's happening is what's going in here is hitting this, and then it's burning off. I'm sorry, there's actually quite a lot of light here to deal with. There's a little, you can say they're random, but it's like it's just best that I can do with my own versions of colorblindness. You know, what am I gonna do? So anyway, so you have these. So there's this part here where it's clearly a different color, and there's a white. So there's a blue circle in there, and you have a blue version over here. And there's some kind of darkness over here because it's clearly visible there. And that also has a light version, but that's different because it's smeared. So that is most likely what a black hole looks like. Is it's a point of light, point of blue, or it could be one of those quasars. You know, I don't know. But anyway, so we're doing this part, and we have this, and we have that. So we have this point of light here, which is clearly tied to this one, and this one, and this one. Oh, sorry, white doesn't work. So that one, and so we have these, we have these different formations. Sorry, I'm just trying to figure this out as I go along. So there's that. I'm wondering if I need to keep track of that for later. Because it's clearly right there. Let's see here. So there's that. Anyway, so we have our little version of a black hole. Material comes in, shoots out there. What's actually happening that I wanted to show you that I saw today was this. So this and this, like this here and this, those are our black holes. Our black hole as I understand it. Black hole as I understand. Okay. And then we have, you can clearly see an Einstein lens here. Right, it's perfectly circular. There's a repeating pattern in the middle. There's these two sides to it that are different, that are the same color, that are clearly mapping something. And then on the other side we have this color. So that happens in black holes when it smears or it lenses so hard that it changes its perspective in space-time when viewed from an outside angle. Yeah. From an outside angle. So there's that. So there's, so that goes there. And as you can see, there's all this output. And what's kind of crazy is, it looks like, at least to me, that this point of light gets repeated a bunch of times. So there's like one here, and then there's one there, and there's one there, and there may be one there, and there's definitely one there. You know, like all the way through. So that might be how it gets torn up, because like this looks like dead space to me. So there's that. Sorry, and back to the black hole. So we have that. So, but what you're seeing here, so this is what's over here near us, right? Out of the way of the black hole. And then, but it's also being pulled in at the same time by this, we'll make that Einstein lens. I'm sorry. I should probably zoom in. I'm Einstein. That's Einstein. It's Einstein or Einstein? Einstein. That's probably wrong. I don't know. Einstein lens. Yep. Anyway, but as you can clearly see, this is tied to this. So all of this, like all of going to this direction, came from here. Which means that black holes, as I understand them, are self-warping in space-time. It might look like an R, but it's a C. Sorry about my writing. My handwriting sucks. Anyway, yeah. We'll add that in up here. That's like empty space. Because like you see that like there's a lens here too. It's just warped. Yeah, I mean like this parallax thing is fun, but I would really like to start showing people how this works. Yeah. And I'm building the computer models to this system so that the algorithms can find all this stuff and more in the stellar cartography that I can provide. And I really hope you'll come and join me when I get that up and running for more people. Yeah, so much pleasure, Jay.